Hi, Mrs McTaggart here, and this is the third video in the Higher Maths Circle series. In this one we're looking at the second equation of a circle, which is sometimes called the general equation, and it's basically like equation 1 but all kind of multiplied out. It's a wee bit messier looking. The good news is it's always given to you in the formula sheet. So what I'm going to do is, if I was doing this in class, I wouldn't get you to write this one down. This is how I prove this new equation. This is basically the new equation here, alright, this thing. And it looks a wee bit horrendous, but I'm going to prove where it comes from, alright? So what I'm going to do is I want to try and make this equation A here look a bit like the equation we had the other day. So I'm going to try and make it look like the x minus A all squared plus y minus b all squared equals r squared formula. So I'm going to make it look a wee bit like that. So to do that, I'm going to just rearrange it and get all the x's to one side. So I'm going to have x squared plus 8x, and then I'll have plus y squared plus 6y plus 12 equals 0. Alright, in fact I'm going to take that 12 to the other side. So I'm going to make that equals negative 12. Okay, so to get, my pen's stopping working. So to get it to look like this is just completing the square. So I'm going to complete the square of the x's here. So I'm going to have x plus 4 all squared. And then I'll subtract 16. And then I'll have y plus half of 6 is 3. So 3 all squared. Then I'll subtract 9. And that all equals minus 12. And then I'll have x plus 4 all squared. I'm going to take numbers all over. So I'm going to have y plus 3 all squared. And then I'll have negative 12 plus 9 plus 16. And in actual fact, what I can do is I can just tidy that up to save myself a wee line of working. Negative 12 plus 9 plus 16 is 13. So I'm just going to make that 13 in there. And then from looking at this, you would then tell me that the centre of this circle is negative 4, negative 3, and you would say that the radius is the square root of 13. Because that would be x squared, right? So what I'm going to do is I'm going to do the exact same with this second one, but it's going to be a wee bit messier because there's loads of letters here, so I'm just going to move things, give myself a wee bit more space here. So doing the exact same with this one, we're going to rearrange it to get the x's to left, so we're going to have x squared plus 2gx, the dodgy looking x, plus y squared plus 2fy equals negative c. I'm going to take that over. I'm going to complete the square. So I'm going to have x plus, well, half of 2 is just 1, so that leaves me with g all squared. I don't know where that little kind of mark where the x's come from, so let's get rid of it. And then I would take away whatever g squared is. Then I'll do the same with the y's. So I'll have y plus half of 2 is 1, so I'm left with an f all squared. I'll take away f squared, and then I'm left with minus c over here. Just to write that out again, x plus g all squared plus y plus f all squared, and then I would take everything over and I would have g squared plus f squared minus c. Now from that I've got letters where numbers would be. You would tell me the centre would be the opposite of plus g, so minus g. You would tell me that the other part of the centre would be the opposite of plus f, so it would be minus f. And then to do the radius, remember r squared is this whole bit here. This is all r squared. So my radius is the square root of g squared plus f squared minus c. So what you do is when it's given in this format, like all expanded out, you get your centre by looking at these two little bits here. And you get your radius, once you've got your centre, by doing your g squared plus f squared and take away whatever this little c is. So here it is right now, how it appears in the past paper sheet. So you are always given it, you just need to know how to use it. One little thing to note is that for a radius to exist, this bit here has to be greater than 0. And the coefficients, i.e. the numbers in front of the x squared and y squared, it has to be 1. There can't be any numbers in front of the x squared. So here is an example. We have to find the centre and the radius. So what we do is, you look at your equation, it's actually got a plus 2gx here. And it's got a plus 2fy under this bit. And it's got a plus c here. So what you do is you equate these little bits. So it says here that 2g equals negative 10. So g equals negative 5. On this one here, if I change my pen colour, we've got all pluses going on here, so that's not too bad. So you've got 2f equals 12, so f equals 6. Our centre is negative g, negative f. So we reverse the signs on what we got. So the negative g, this negative 5 here, becomes positive 5, and this positive 6 becomes negative 6. And then your radius is plugging in your g, your f, squaring them, and then subtracting c. So c here, if you look at this bit, c is negative 11. So when we plug these in, we have g was negative 5 squared, plus f was 6 squared, and then we had to minus 11. So you should be familiar that becomes a big old plus. So what we have is, we have essentially 25 plus 36 plus 11, which gives us r is the square root of 72. And again, quite often it's nice to leave it in its simplest form. So the actual radius using surds would be root 36 root 2. So our radius would be 6 root 2. And our centre 596. Now that's one way of doing it, doing all the equating, but there is a trick, okay? I don't know if you've noticed, but the trick is simply, we had minus 10 in front of the x, our answer became 5. So what we've done is we have halved the coefficient and flipped the sign. If you look at the f, half of 12 is 6, flip the sign becomes negative 6. So you get to the point that you do that trick, but for the notes I always introduce this way where you're equating it, okay? Right, here's the same, another one, we're going to do the exact same. So this is your 2g, this is your 2f, your centre is negative g, negative f. Our radius is g squared plus f squared minus c. And we're going to try and do this one without actually having to do the wee equations and work out what 2g etc. is. So my centre is, so if you equate these two bits, g is obviously the number 4. We need the negative of that, so negative 4. If you equate these two, f is negative 2 because there's a negative in front of the 4. We need the opposite sign of that, so it becomes 2. So half it changes sign, we also get to there as well. When you come to plug in the radius, you might get confused. So am I plugging in 4 or minus 4 and then squaring it? To be honest, it doesn't really matter. It is perfectly acceptable to actually square this number rather than writing minus 4 all squared or 4 all squared. So whether we're using minus 4 or 4 and you square it, you get 16. The f value was negative 2 or 2. When you look at the centre bit, negative f, so 2. Either way, 2 or minus 2 squared gives you 4. And then c was positive 6, so we're taking away 6 on this one. So 16 plus 4 is 20. Take away 6 is 14. So this one would just be the square root of 14, which as a surd doesn't simplify at all. So there is your centre and there is your radius. Just be careful when you're plugging in the c value that you're not missing out on a double negative or anything like that. And if you ever come out with a negative in the square root, it means you've probably done something wrong with your c value. Okay, question 2. This time it's from a picture and we're asked to find the general equation of this circle. Now I did an example like this in the last video when we were using the other circle equation. So for this one we're just going to do something a wee bitty different, okay? So our centre is 2, negative 3. So that was our negative g and our negative f. So that means that g is negative 2 and f is positive 3. So we are going to plug them into the equation up here. So we're going to have x squared plus y squared plus g is negative 2, and there's a 2 in front of it, so that's going to give me, I'm a bit quick to put that plus down, that's going to give me a negative 4x. Plugging in f is 3 would be 2 times 3 is 6, so I'll have plus 6y, and then I've got this plus c. So we get to here and you think, God, what do we do with the c? Now there's one other bit of information I've given you. I gave you this coordinate on the outside and I told you that was your x and that, and I told you anytime you get a coordinate in maths, it means you've got a value of x and y. So if I plug these in, it will give me what c is. So minus 1 all squared would just be 1. 4 squared for the y would be 16. Take away 4 times negative 1 would actually turn into a plus 4. 6 times y would be 24. And then I've got my c equals 0. Let's tidy up all these numbers. 16 plus 4 is 20. Plus another 24 is 44. It gives me 45. So I've got 45 plus c equals 0. So c is obviously the number minus 45. So the equation of this circle is x squared plus y squared minus 4x plus 6y negative 45 equals 0. Now, in an exam, you probably wouldn't use this one unless they asked for it in that format. It's perfectly acceptable to go do what we did last time and find the radius and plug into the first formula, but it just depends where the question's going or if it gives you a particular layout to do it in. Alright. I much prefer the other formula for doing this question, I'll be honest. Okay, so here is my example 3. So for what values of k does this represent a circle? So if you remember when I introduced the formula, we said for a circle to exist, that radius formula where we did g squared plus f squared minus c, we said that for that to work it had to be a positive number because you can't square root a negative. So basically what we're saying is that this has to be greater than 0. The opposite of square rooting something is squaring, so you'll do 0 squared, which is still just 0. So essentially, this bit here has to be greater than 0. Alright, so let's get our f and g values. So remember, this is your 2g, this is your 2f. So you've got 2g equals negative 2k. So g is going to be replaced with negative k. You've got 2f equals negative 4, so f is going to replace with negative 2. And our c value is everything without letters, so your c value is going to be that bit in the square. So let's put these in. So we're going to have negative k squared plus negative 2 squared, take away bracket k squared plus k minus 4 is greater than 0. Let's tidy this up. So negative take k squared is k squared. This gives us plus 4. Multiply out the bracket by minus 1. You end up with that. Tidying up, well there you've got a k squared, take away k squared because they'll disappear. So we have 4 plus 4 is 8, take away k is greater than 0. I'm going to take the 8 over, so you have negative k is greater than 8. And remember in maths, if you're dividing by a negative, then you flip the sign. So you get k is less than negative 8. So that is the value of k. That makes this a circle. Okay, another example. I've told you at this point lies on the line. Find the value of b. Same old, whenever you give a coordinate, you're given a value of x and y. So we're simply going to plug them in. X gets replaced with p, so we've got p squared. Y gets replaced with 9. Sorry, y gets replaced with 3. I'm thinking ahead. 3 squared gives me 9 here. Take away 8p. Minus 6 times 3 is minus 18 plus 9 equals 0. The numbers here are going to disappear because 9 add 9 is 18, take away 18 is gone. So we get down to this. We'll then do a common factor, leaving us with p minus 8 equals 0. So p is either 0 or p is the number 8. Two possibilities here. Alright, and that's that one. And it just said find p. Probably should have said find values of p if I was going to be a bit more exact. So I know I've got loads of examples in this video. Bear with me. This one looks like it's been snapped from a past paper. We're told that the diameter of the circle ST has endpoint S31. So I'm just going to draw a little picture. So this is going to be my S. This is going to be my T, and I'm going to say that that is 3, 1. They want us to find the coordinate of T. So a good place is whenever you're given an equation of a circle, go find the centre, right? So the centre for this one would be negative G, negative F. My pen's not working. So C would be, well, there's my 2G. So remember, you can do the trick if you want, half it and change the sign. So negative 4 halved and change to a sign would be 2. And 6 halved would be 3, change the sign would be negative 3. So my centre is 2, negative 3. Now, this is just a sketch. It doesn't match at all. In fact, let's make it match because that's going to annoy me. So my sketch again actually doesn't need to match at all. I'm just being a wee bit panicky since this is a video. So we said the centre was 2, negative 3. S is 3, 1, so this would be over this direction. So T is actually back the way. Alright? Right, we're going to do what's called stepping out. So what I've done is I've just made this a little bit bigger so that I can draw my stepping out on it for you. Okay, so we know that S was 3, 1. So let's put that in my picture. This is 3, 1. We're going to draw some triangles, stepping down and over. It's not the most wonderful drawing, but you get the idea. Right, you then look at what's happening between your coordinates. We are going from 3 back to 2, so it's gone back 1. So we go back 1 again from 2, which makes T at the point 1. Then we look at the Y's. It's gone from 1 to negative 3, so it's gone down 4. So we need to go down 4 again from negative 3, which makes us negative 7. So to finish things off, T is the point 1, negative 7. And that's what's called stepping out. Because this is basically the centre to S and T are both radiuses, like whatever kind of pathway or route you take from the centre to S, you do the same backwards to T. And it's called stepping out because when I draw it, it looks like little steps. You'll see a lot more of that later on. Right, I've got one more example if you're still with me here. Determine the point where the point 4, negative 2 lies in relation to the circle. So this comes up quite a lot, alright? Simply the easiest way to do this one is do X and Y. If you plug this in, if it lies on the circumference of the circle, then you would expect to come out with 0 as your answer. That point would do what's called satisfying the equation, okay? If your answer comes out and it's bigger than 0, you lie out with. If your answer comes back and it's less than 0, you lie inside the circle. So let's have a look what happens when we plug in the numbers 4 and negative 2. So X will get replaced with 4, Y will get replaced with negative 2, and I'm putting in all the work in for this one. 10 times negative 2, negative 70. And I'm not putting equals 0, I'm just going to see what we get. I'm going to put that negative in there. So we have, oops a daisy, that should have been 4 squared. So we'll have 16 plus 4 plus 24 plus 20. And let's add this up. Well, this is 20 and another 20 is 40 plus 24 is 64. Now it didn't equal 0. So since 64 is less than 70, 4 negative 2 lies inside the circle. Now there is another way of doing this one. So here's the same question again, but without the writing. What I'm going to do is I'm going to go at the centre of the circle. So the centre of the circle would be half of 6, change the sign, gives me negative 3. Half of negative 10, change the sign, gives me 5. My radius would be the square root of negative 3 or 3 squared, which is 9, plus 5 or negative 5 squared, which is 25, and it would be minus 70, which turns into a big old plus 70, giving me that my radius is 70, 95, plus another 9 is 104. Okay, then what I'm going to do is get the distance between the centre and the point. So my distance would be the square root of, and then I'm going to compare the 4 to the negative 3, that's a distance of 7, so 7 squared. Compare the negative 2 to 5, that's a distance of 9, so plus 9 squared. So that's 49 plus 63, which is 112. They don't match. So if my point lay on the actual circumference, my distance would match the radius, and it doesn't. So in this one, I could say, well, root 112 is greater than root 104, so the point 4, -2 lies outside the line. Both versions work. It's up to you which one you like. Alright. This method I would use if it maybe prompted you to ask the circle or something first. Right, and I apologise, but I just think there's so many different things to cover on this lesson with circle. If you're still with me, thanks for watching, and I hope this has helped. Bye bye. This has been a really long